Going to work some problems from review problems here for chapter 6 through 7.5. I'm having issues with my pen. I don't know why it's so faint like this. I know it's hard to read, but that's the best I can get it to work so far. So we'll see if we can make it work. So starting with a negative 2e to the x minus 2, our parent function e to the x is an exponential growth. So that's where we're starting. The negative 2, the negative part is going to reflect it in the x, and then the 2 is going to be a vertical stretch, so every y value gets multiplied by 2, so it'll still keep the same asymptote, but that's y-intercept is now going to be at 0, negative 2. Then we're going to move everything right 2 and up 1, so going right 2 and up 1 is going to move that point that was at 0, negative 2 to now be at 2 comma negative 1, and it's going to move that asymptote, which was the x-axis. Right 2 doesn't make any difference, but moving it up 1 is going to make it now be at y equals 1, and our curve is going to be that reflected and stretched exponential growth curve. So it's going to be what we see in the red there. Okay? Now the logarithm, our parent function for a logarithm, is going to cross the x-axis at 1, 0 and have the y-axis as an asymptote. The negative inside the function is going to reflect it in the y-axis. So now it's still going to have that same vertical asymptote, but our important point has moved from 1, 0 to negative 1. And then we're going to move every point left 3. Oh, I don't know why it's doing that. So we're going to move everything left 3 and down 2. So this point is going to get, that's at negative 1, 0. It's going to go 1, 2, 3 more left, down 2 is going to put us at this point, which is going to be negative 4, negative 2. And our asymptote, that was the y-axis, is going to get moved. So that's now going to be here at x equals negative 3. And our curve is going to be that reflected in the y-axis logarithm curve. Okay? Let's slide down here a bit. So if the graph of y equals f of x contains the point negative 6, 2, then what point must be on the curve y equals negative 1/2 f of negative 2x plus 3 minus 15? Holy smokes. Now the stuff on the inside has to be equal to that negative 6. So whatever we choose for x, after we add 3 multiplied by negative 2, has to equal negative 6. That is, negative 2 times x plus 3 must equal negative 6, which means if we divide by negative 2, that x plus 3 must equal 3, which means that x must actually be 0. Now, once we plug in 0, then 0 plus 3 is 3 times negative 2 is negative 6. That's going to make the y value be 2. So f of negative 6 is going to be 2. That will then get multiplied by negative 1/2. So we're going to get negative 1/2 times that 2, which will be negative 1. And then we'll subtract 15 from that, which will get us to negative 16. So our point is going to be 0, negative 16. So if the same function in the transformation has the original function f has our domain negative 6 to 14 and range negative 2 to 10, what will be the domain and range of our g of x function after we've transformed it? Well, we can think of that negative 2x plus 3 has to, after it does all this transformation, has to still end up being between the negative 6 and the positive 14. So it's got to fall within that same domain of the original function f. So if I divide everything by negative 2, then this will become 3. We'll switch the inequality, and we'll switch that inequality, and that will be a negative 7. I'm going to rewrite that negative 7 less than or equal to x plus 3 less than 3, just so it goes from small to large. Then we'll subtract 3 from everything and get negative 10 to 0. And this will be our new domain of that transformed function. Then the range, we're going to multiply, so we have our negative 2 less than or equal to y less than 10. Everything is going to get multiplied by that negative 1/2, so that's going to make that be 1. We'll switch the inequality, and that'll become a negative 5. And I'm going to rewrite that again from small to large, although you don't have to. It's still correct the other way. And then we're going to do what? Subtract 15 from everything. So that'll become a negative 20. And that will become, if we subtract 15 from the 1, it'll be a negative 14. And that is going to be the range of our transformed function g of x. All right, let's slide this up and see if we can do some graphing of sine and cosine. So let's see what we've got here. So we are going to say that our period is going to be the natural period 2 pi divided by that 1/2 is going to become 4 pi. That means what I call the critical points, the spacing between tick marks, is going to be pi. Our starting value is going to be pi over 4. So that's going to put us at pi over 4. If we add pi to that, that's going to be 5 pi over 4. And another pi added to that will be 9 pi over 4. And then we'll get to 13 pi over 4. Going to have to extend that a little bit. And we'll get to, let's see, 17 pi over 4. So our midline, the middle of our graph, is going to be at 1. That's our translation vertically. So I'm just going to put that in as a guide. Our amplitude is going to be the absolute value of a, so that's going to be 3. So that means our graph will go to a high point that's 3 above the midline and to a low point that's 3 below the midline. I'm just going to put a little guide there so I don't forget what we're aiming for. Trying to make my graphing go a little bit easier. So we're going to start with a sine curve, starts in the middle. So at pi over 4, we're going to start right at the midline. Because it's a negative sine curve, we're going to go down first, then back to the midline, then to the high point, and end up at the midline again. And this is going to be our sine curve. I'm going to slide this over a little bit if I can. Create some space for our cosine curve. So in our cosine curve, first we're going to have to factor that pi over 6 out so that we can see the difference between our horizontal stretch and our translation horizontally. So our period is going to be 2 pi divided by pi over 6, the thing that's multiplying x. So that's going to be 2 pi times the reciprocal, like Pi's will cancel, so our period is going to be 12. So our critical points are going to be every fourth of a period. So that's going to be every 3. We're going to start, our starting value is going to be at -1 because of that +1. So there's -1. We're going to go over 3, so it's going to put us at 2. And then 3 more is going to put us at 5. 3 more will put us at 8. And 11, so that's 1, 2, 3, 4, 5. That should work. Our midline is going to be a -1. So we're going to go here. Is going to be the middle of our graph. Our amplitude is going to be 2. So that means we're going to go up 2, and that's going to kind of be the ceiling of our graph here at 1. And down 2 will put us at -3. Is going to be the floor of our graph. We won't go any lower than that. And so a cosine starts big, so at x equals -1, we're going to be at a high point. The next critical point over will put us in the midline, in the middle, and then to a low point, back to the middle, back to a high point, and we'll try to connect that with a smooth cosine curve. Okay, let's slide back and up. And now we're going to try to find an equation from the graph. So we have a low point and a high point. So let's see what we can do. We can think of this probably easiest as either being a negative cosine that starts here or a positive cosine that starts there. I'm going to just pick it to be a negative cosine. And that means that it's going to start at -π/3, which will make that be an x plus π/3. We can see that our amplitude is going to be the top minus the bottom divided by 2. So 6 minus -4 divided by 2 is 10, divided by 2 is 5. That's going to be our vertical stretch. Our midline, our translation vertically, is going to be right in the middle. And since our amplitude is 5, if we go up 5 from the low point at -4, that's going to make this be a +1. And then always the hard part is finding that b. So the b is going to be our natural period. And since we're in radians, that's 2π, divided by our actual period, which we're going to have to figure out. Let's see. Our period now, going from a low to a high, is not a full period. That's actually half of a period. So 5π/6 minus the -π/3. Let's see, π/3 is 2/6. That's 7π/6. That's a half period. So if we multiply that by 2, we can cancel, and that'll be 7π/3 is the actual period. So our b is going to be 2π over 7π/3. That's 2π times 3 over 7π. We can cancel the pi's, and that is going to give us, I think, 6/7. So our b is going to be 6/7, and that's going to go right there. That's one equation of that curve. Now for the blue one, same idea. We have a high point to a low point. Since we know the high and low points, I'm going to think of that as being a cosine. And I'm going to think of it as starting here, which is going to make it be a positive cosine. We can see if it's starting at 2 degrees, that this is going to be x minus 2 degrees, is going to be our translation to the starting point. We can see that our amplitude is going to be top minus bottom divided by 2. So that's going to be, that should have been a -3 there. So that's 15 minus -3 over 2, which is going to be 18 over 2, which is 9. That's the number that's going to go here. And we said that's a positive cosine. the midline, that halfway point, is going to be, we're going to add 9 to that negative 3. So the negative 3 plus 9 will make that be 6. So that's going to be a plus 6. And now finding the b is always the hard part. Remember, our b is going to be the natural period. And since we're in degrees, that's going to be 360 divided by the actual period. So our period, well, let's see, half of a period. So half of a period is going to be that distance we travel from the high to the low. So 26 minus 2 is 24 degrees. That's our half period. So our period is going to be 24 times 2 is going to be 48 degrees. So that means our B is going to be 360 divided by the 48. So let's see, what do we do with that? 9, let's see, 48, I'm blanking here. 12 goes into there 4 times, 12 goes into there 30 times. So I think 15 over 2 is going to be our B. So that's going to be a 15 over 2. And that will be our equation. Let's slide down and see what else we got here. Now these are ones we need to know from memory, or sort of from memory, if not exactly. So if we think of 5 pi over 6, if we go, there's 1 full pi, which is 6/6, back up 1/6 pi, there's going to be our angle of 5 pi over 6. That reference angle is going to be pi over 6. That's going to put us into quadrant 1, where we know that pi over 6 is that first one, that first angle. So since a sine starts small, that's going to be 0, pi over 6 is going to be 1/2. In quadrant 2, sine is positive, so that means we're going to have 1/2. Sine of 5 pi over 6 is 1/2. Now, cosine of 4 pi over 3, I'm going to think of that as 1 1/3 pi. There's 1 whole pi plus another 1/3 pi is going to take us down into quadrant 3. The reference angle here is pi over 3. That puts us back into quadrant 1. Let's see, that's 0, pi over 6, pi over 2, pi over 3 is going to be here. 1, 2, 3, 4 clicks. Cosine starts big, so that's going to be 1, square root of 3 over 2, square root of 2 over 2, 1/2. So this is going to be 1/2, but in quadrant 3, cosine is negative, so it's going to be a negative 1/2. Now we have tangent of 3 pi over 4, which we're going to think of as sine 3 pi over 4 over cosine 3 pi over 4. So let's see. There's 0, 1/4, 2/4, 3/4 pi is going to be right here in quadrant 2. The reference angle here is going to be 4/4 minus 1/4, so the reference angle is pi over 4. So that puts us into quadrant 1. There's 0, pi over 6, pi over 4. That's the place where sine and cosine are both square root of 2 over 2. So this is going to be square root of 2 over 2 over square root of 2 over 2, which is 1. But we're in quadrant 2, where the cosine is negative, but the sine is positive. So a positive over a negative is going to be a negative, making that tangent be a negative 1. Sine 3 pi over 2, 3 pi over 2 is 1.5 pi. That's putting us right here on the y-axis. So if we imagine the unit circle, and the coordinates of that point on the unit circle are 0, negative 1, sine is the y-coordinate of that point, so that makes the sine equal to negative 1. Okay, let's try the next ones. So what are the values of theta? And we want all the angles between 0 and 360 in degrees. and all the angles between 0 and 2 pi in radians, for which sine of theta is negative square root of 3 over 2. So let's ignore the negative sign for a moment and imagine that we're in quadrant 1. So let's see, sine starts big. So there's, at 0 it's going to be 1, and then it's going to be square root of 3 over 2 right here at pi over 6. So our reference angle is going to be pi over 6. Now we got to think which quadrants is sine negative in. Since sine is the y value, that's going to be in quadrant 3 and in quadrant 4. So the quadrant 3 angle is going to be, there's 1 pi, which is 6/6, plus another 1/6 is going to make theta equal to 7 pi over 6. Now the quadrant 4 angle, we can think of that as being 2 pi, which is 12/6. Back up 1/6 makes 11 pi over 6 as the second angle, where sine is going to be negative square root of 3 over 2. Now that's in radians. In degrees, this first angle would be 30 degrees. And so our first angle in degrees would be 180 plus 30, which would make that be 210. And we would get 360 minus 30, which would be 330. So there is our angles in degrees. So let's think about, ignore the negative sign for a minute. Let's get our reference angle. And maybe you remember that sine and cosine are both square root of 2 over 2 at pi over 4. So our reference angle is going to be pi over 4. And which quadrant is cosine negative in? That's going to be in quadrant 2 and in quadrant 3. So in radians, we can say that this is going to be 1 pi back up 1/4 pi. So that's 4/4 minus 1/4 means that's going to be 3/4 or 3 pi over 4. The quadrant 3 angle is going to be 4/4 plus another 1/4. That's going to make that be 5 pi over 4. So there we have it in radians. In degrees, our reference angle is 45. Whoops, lost my pen there. It's 45 degrees. So in quadrant 2, that's 180 minus 45. That's going to be 135. And in quadrant 4, that's going to be 180 plus 45 is going to be 225. So there's our angles in radians and degrees. Now, tangent, this is a little tougher. So we can think of this one of two ways. If you've done a couple million of these like I have, you know that a tangent is going to be sine theta over cosine theta. And this square root of 3 is going to have to come from a known value, which means it's going to have to come from square root of 3 over 2, which means to cancel that 2 in the denominator, we must get a 1/2. So then I can say the same angle that makes sine theta square root of 3 over 2 makes cosine theta 1/2 and makes tangent theta square root of 3. And that angle is going to be that first angle, pi over 6 or 30 degrees. So that's one way to do it. But like I said, that takes a little bit of experience and understanding with sine and cosine. A second way that is fail-safe is to draw a reference triangle and say this is the angle whose tangent is square root of 3. That means that the opposite is square root of 3 and the adjacent is 1. And now you can do Pythagorean theorem to get the hypotenuse. Square root of 3 squared is 3, plus 1 squared is 1, 3 plus 1 is 4, square root of 4 is 2. Now you can turn it into one that you're more familiar with. So instead of trying to get a tangent, say this same angle has a, sine of square root of 3 over 2, and now we're back to the same place we were before. But that's not going to be 30 degrees. I did that wrong. Hold on. So that's actually, cosine would be square root of 3 over 2 at pi over 6. So sine starts small, so it's going to be 0, 1/2, square root of 2 over 2, then it's going to be square root of 3 over 2 at pi over 3, or 60 degrees. So our reference angle is either pi over 3 or 60 degrees. Tangent is going to be positive in quadrant 1, where sine and cosine are both positive, or in quadrant 3, where sine and cosine are both negative. So that means in quadrant 1, theta can be pi over 3, or it could be 30 degrees. Not 30 degrees, 60 degrees. Boy, my eraser doesn't work very good in this weakened state here. 60 degrees. Or in quadrant 3, that's going to be a reference angle of pi over 3. So that's 3/3 plus another 1/3 is going to make that 4 pi over 3. Or 180 plus 60 will make that 240. So there are those angles. All right. Let me slide this up a bit. See if we can draw an angle theta and also find and draw its reference angle. So a 200-degree angle is going to go clockwise. So we're going to go, there's 90, there's 180, and another 20 is going to take us to, I'm going to put a little arrow on there. This is our terminal side, and this is our angle theta that we're showing here, going in this direction. The reference angle is this angle, so I'm going to say theta reference. It's always the acute positive angle to the nearest x-axis. So that's going to be a 20-degree angle. Now the 730, let's see, this is positive. So we're going to go, there's 360. And if I went all the way around a second time, that would be 720. And then another 10 degrees is going to take us here. And so this is our angle theta. And we can see that we've gone around the circle twice. And our reference angle is going to be 10 degrees. It's always positive, always acute, always going to the nearest x-axis. All right, let's find the complement and supplement of these angles. So the complement is going to be the angle that when you add it to 24 adds up to be 90. So the complement is 90 minus 24, and I think that's going to be 66 degrees. The supplement is what will add up to be 180. And so if we subtract 24 from 180, I think that's going to be 156. So there's our complement and supplement. Now, the way we do that for an angle in radians is a 90 degree angle in radians is pi over 2. So we're going to subtract our 2 pi over 7 from the pi over 2. So we're going to need to get common denominators. So it's going to be 14. And so if we multiply top and bottom by 7, that's 7 pi. And then multiply top and bottom by 2 makes that 4 pi. So we'll get 3 pi over 14 is our complement. And the supplement is going to be pi minus our angle. So that's going to be 7/7 pi minus the 2/7 pi is going to be 5/7 pi, or 5 pi over 7. I think that's it for this one. Okay?